Okay, good afternoon. Welcome to From the Field, Farm Chat with Idaho Wheat. I am Brittany. I'm the Executive Director of the Idaho Wheat Commission. And we are joined this episode by Juliet Marshall, who is a professor and department head of plant pathology. Did I get that right, Juliet?
Yes.
Okay. At the University of Idaho. And we are talking about falling numbers. So I want to remind you that you are welcome to ask questions at any time. You can do that by just unmuting your microphone. You can use the reaction button down at the bottom of your screen to raise your hand, or you can type your question into the chat, and we will make sure that those questions get asked. So, Juliet, I'll let you go ahead and introduce yourself first, and then we can just kind of start off with this year we had late harvest. We had a late harvest anyway because of the long spring and a lot of late harvest rains. And what did you see with falling numbers this year because of that?
Well, for the extension variety trials, we haven't run our falling numbers as a result because we're still actually finishing the harvest. But in general, when it comes to what we're seeing with falling numbers, a number of reports of falling numbers, issues in sprouted grain, whether you're talking barley or wheat, and all of that is mostly associated with the sprout damage. Now, there probably are instances due to the weather-related, LMA-related falling numbers issues, but right now, at this point, we really can't differentiate the difference due to the extensive amount of precipitation that we've had on grain that's been ripe and ready to harvest. So a lot of what we're seeing is directly related to sprout damage associated with just odd amounts of precipitation in times when we normally don't see it.
I saw one, but don't let me forget.
Juliet, can you explain to us what the falling number test is and what exactly it measures?
Okay. Sorry, I didn't know if there was a follow-up question. So probably it's a good thing for me to try to share my screen and to explain what the falling number test is all about. So I'll share my screen to, well, if I get permission from Brittany, I can go ahead and.
I just made you a co-host, so you should have it now.
Aha, there we go. Do you see the interpretation of falling numbers and on my screen?
Yes, yes, we do.
Okay, so if we want to talk about what the falling numbers test is, it's just a way to measure or interpret the overall quality associated with grain starch physical properties. And so the test itself is not measuring enzyme activity, but it's actually measuring properties of the starch. And so that falling numbers test can give an indication of quality as affected by sprout damage is what we typically are looking for. And in the more recent past, say the last 10 to 20 years, it's actually been utilized to take a look at what's called late maturity alpha amylase issues. But if you're looking at what the falling numbers test is, it's basically a measurement associated with whether or not that starch quality is really good at measuring pasting, or kind of like measuring gravy associated with the different engines or flours. So the falling numbers test is usually measured through a machine that pretty much grinds about 300 grams of grain. And it's not a flour per se, it's more of a ground meal that they then can take that, measure it, and put it in a tube. This tube is heated in a water bath, and then a plunger is utilized to mix that paste and water and process. During the heating process, it will form a paste or a gravy, and how thick that is measured by how fast this plunger actually decreases in the paste mixture. The faster it goes, the more damage there is to the starch, and the lower the falling number value. So our falling number value, we really want to see above 300, but when you start to see enzymes that have caused some impact on the starch qualities, that falling number quickly goes below 250 seconds. So that's what the falling number test is. That's the measurement that we're looking at. That viscosity is really important when it comes to the end use quality of a. So again, the faster falling number, the lower that falling number actually is, and the higher either the alpha amylase activity is due to sprout damage or to late maturity alpha amylase. So what we're looking for at this juncture and this season, we're actually looking for impacts associated with sprout damage due to the late rains. So any other questions, or what else would you like to focus on?
Juliet?
Yes.
So if I'm understanding, is it mostly just weather, wetness that causes this, or is there other causes that cause the low falling numbers?
This season, what we're looking at is almost always sprout damage. Now, we could have late maturity alpha amylase that is induced by environmental conditions during grain fill, but because we have such widespread rain events before harvest, most of what we're looking at is sprout damage that is either masked LMA or just straight sprout damage. So we've got a large number of issues. So falling number above 300 is what we really want, 300 seconds. A falling number between 300 and 200 often is some level of sprout damage. And of course, 200 and less than 200 falling or seconds is severe sprout damage. So that's mostly what we're looking at, is sprout or rain events causing sprout damage and deterioration in the quality of the starch.
Thank you.
Julia, are there particular classes or wheat varieties that are more or less susceptible to the low falling numbers?
That's a very good question. And the answer is yes. One of the nice things about some of our hard red grain is that hard red grain is a little less susceptible to sprout damage, and actually a lot less susceptible to sprout damage. So given that, the whites, the soft whites, and especially the hard whites, are more risky of sprout damage associated with rain events on the grain. So in essence, growing hard white winter or hard white spring places more of the risk on our growers, more risk, because the growers aren't getting necessarily paid for growing hard white. They're not getting paid more per se, but the risk increases of problems associated with not being sprout tolerant. The hard whites are a lot less sprout tolerant than the hard reds. And also we're finding quite a lot more late maturity alpha amylase issues with some of our hard white, but definitely the hard whites are more susceptible.
Anything farmers can do to minimize that risk?
Grow hard red. So,
Corey, you have a question.
Yeah, I never know how to work this on my phone, only my tablet, but expand on that. I always assumed it was just soft wheats that were so much more susceptible. I mean, you put a soft wheat in the ground and it'll germinate 2 or 3 days faster than a hard wheat.
Yes.
But you're saying it's more color, the whites in general. I kind of thought hard white would be less problematic than say soft white, but you're thinking it's more in line with soft white, huh?
Yes, because the reason why hard red and especially soft red wheat is predominantly grown in the Southeast and in areas of the Midwest is because whether it's soft red or hard red, it has higher levels of tannins that are instrumental in shedding some of the impact associated with excessive rain. So you can grow a hard or a soft red in areas where a tendency to late season rains, because due to the physiology of the seed, the tannins, etc., they are less susceptible to sprout damage. Of course, that also consequently means they're also slower to germinate and emerge from the ground, because whether it is there's more dormancy as well in some of those than there is in the whites. So if you really want something to emerge fast from the ground, of course, the soft whites are going to be able to absorb the moisture and bounce out of the ground a lot faster, as are the hard whites, but especially the soft whites. So it's not necessarily just a class issue, Corey. It's also a color issue.
Yeah, that's interesting. And I'm kind of hearing that some of the hard white spring has been pretty affected. There's a lot of regions still cutting, and it's not great, and it's about to get a whole lot worse starting tomorrow, I think.
So elaborate a little bit more on the regions that are still cutting, Corey.
I don't know if any of them are on this call, but most of the Soda Springs area is still going.
Yeah.
And little bit up to Antelope Flats, Swan Valley area, I know. So
yeah, okay. I definitely would agree with you there. Some of the issue has been the fact that we've got in some areas a very late planting, and that cool spring has really delayed the crop advancement as far as crop maturity goes. So we had a really nice spring, and the longer that cool period of time was occurring during tillering, of course, the crop tillered better, it grew longer. And then when it came to actual having time to dry down and finish, we're way behind. So we didn't cut some of our Soda Springs spring wheat because it was so far behind the barley that we were still trying to hope that it could dry down to a nice level below 14%. So yeah, that definitely increases the risk of sprout damage when you have such a late season.
Well, to further complicate that, it's going to be interesting to see how it all comes in. They're still fighting green over there, so some of it might not be quite fully mature, so maybe it won't get hit as hard. It's just a weird year.
I don't know what a normal year looks like anymore, but the thing to remember though is if you are interested in trying to mitigate some of the impact and you want to grow some hard white, the only thing that I know of is to invest in some drying bins, trying to figure out ways to dry the grain to acceptable levels when you're harvesting at higher level moisture. Did that answer your question, Ryan?
Yes. Speaking of the bins, Juliet, can FallingNumbers increase if the grain is being stored?
There's a lot of questions in regard to that, and I've talked to Lee Anderson. Talked to Lee Anderson, for example. under the impression that if you left the grain in the bin for a little bit longer, it could actually improve the falling number. And that is not the case. As far as I'm aware, that is definitely not the case. What we have to remember is that we're looking at measurements that are plus or minus, say, 2 to 5%. And when you're talking variability in measures, you can end up having a 30-second difference in falling number just by measuring it again, whether it's later, or sometimes it might actually be to your detriment. Instead of being 30 seconds better, instead of having 270, you have 300, which is acceptable. You might actually have a measurement that ends up being 250, which makes it worse. So it's mostly that improvement seems to be more related to variability in the testing methodology and not as much towards just the grain, say, sitting and maturing in a bin. There could also be some implications associated with moisture. If you are measuring a higher moisture content, you're measuring the falling numbers associated with that higher moisture content, yeah, that may actually impact falling number and make it lower. So you do want to make sure the falling number measure is on the grain that is at the right moisture that you're going to actually sell it at.
I'll add a little bit to this as I try and think back to 2014 and the last time we had all this fun. Don't take one test as gospel. I was hauling wheat down to Ogden at that time, and walking in, you'd get every truck graded before you'd go dump at the grain inspection. And I'd walk back and visit with the inspectors or the graders and talk to them. And I was down to running the sweep, and I had a bin where there's 3 loads in once you start the sweep. And if you've ever filled a bin and empty it, you know all 3 of those loads are pieces of the exact same pie. They come off the same place in the field. They're the same grain, essentially. I had numbers range from 300 to 450 within those 3 tests, and it was the same wheat. So I've just been super skeptical of this test ever since then. It's hard to get a good measurement. If you read the specs, you're supposed to use filtered special temperature water and all this. They were using city water. I kind of wondered if the chlorine was affecting it, things like that. So I guess my advice with that whole story is, get several tests before you say it's junk or you say it's good or you go with it.
I'd agree with that, Corey. There's been a number of anecdotes where a grower has delivered their grain, found it has a low falling number, came back the next day with the same load, and it had a different falling number, which was acceptable. So sometimes it might be just as simple as testing it again the next day with the same load and getting a different falling number. If you think about it experimentally, under our laboratory conditions with trained personnel, we're talking still having that 30-second plus or minus value. So if we're having that under very stringent lab conditions, then having somebody test it very quickly under some of the more difficult conditions in the elevator actually increases the risk of having a lower falling number.
And Juliet, there's no way to, we blend wheat all the time for protein levels and that sort of thing, but there's no way to blend off low falling number. Is that correct?
I will share my screen real quick and show you this chart that indicates that falling number is very much not quite capable of being blended off. So the reason why I want to say that, if you take a look at this chart, and Dr. Andrew Ross at Oregon State University developed this chart, you can see that you have grain with a falling number value from 0 to 600. And of course, falling number about 50, 100, 150, 200, that's going to be soup. It's not going to be gravy. And then if you talk about anything over 300 to 350, these falling number tests are pretty much measuring, it's irrelevant. If you've got something over 300 to 350, that's all you need to know. But you add 1 seed in 500 with visible sprout, then you could see that it will drop the falling number significantly, all this SKB units. So 1 seed in 500 can drop that number from 300 to, let's say, 265. So this is good harvested grain with no visible sprout. This is 1 kernel in 500 that has some visible sprout, and it dropped it from over 300 to about 260. So 1 in 100 seeds will also drop it pretty significantly. And of course, you're talking a lot of visible sprout in 1 in 100 seeds, and you're looking at below 200. So what I wanted to point out with this particular chart is you can blend it off, but it takes a heck of a lot of healthy grain to counteract the effects of 1 kernel being visibly sprouted or visibly damaged. So what it's telling you is that the enzyme activity has been stimulated in these, and as soon as you add any additional water, that alpha amylase activity is very visible in even a minute amount of visible sprout. Did I make any sense with that? So technically, you're not supposed to blend it off. The best thing to do, if you're looking at long-term viability of the crop, is, or if you're looking at from a marketing standpoint, if somebody wants to buy some healthy grain for their end product, they don't want any sprout. Because 1 in 500 seeds can affect the end use quality of what they're trying to make, whether it's sponge bread, whether it's bread, whether it's any different types of products for milling and baking. I can actually show this particular slide as well. These are steam buns and noodles, and you can see that the control looks really great, but as soon as you start adding rain, you actually seriously translate or affect the amount of quality, whether it's for noodles or steam buns. And this is the control here, and you add a little bit more.
We can't see your slides, Juliet.
Oh, I thought I shared it. I'll try it again. Can
There
you
you
see
go.
this?
Yeah.
Okay. So this is the control steam bun here. And you add 60 hours of a rain, 69 hours of a rain, and 84 hours of a rain. And you can see the quality deteriorate on the steam buns. And it's the same with these noodles. The control is nice and clean. You add a little bit more of rain simulation after harvest. This is a 60-hour. The more that you add, of course, nobody wants gray and brown noodles. So, and of course, it affects the ability of the micromulter, or it affects the ability of the bread maker to manufacture in a consistent fashion. And when you're talking large quantities, a small baker might be able to make adjustments, but these large milling and baking operations can't make adjustments with their massive large-scale equipment to be able to accommodate large swings in falling number and quality.
So is it generally just color that changes on the end use?
No, it's not just color. It's the ability of the proteins to form good disulfide bonds, and because the proteins are being degraded too, as well as the starch. So it's just the overall quality of whatever it is you're trying to produce that degrades rather rapidly. Now, there are some functions that aren't necessarily required to have a 300 falling number. If I remember correctly, was it Graincraft used to talk about some of make like flatbreads really aren't as affected by falling numbers as other end use breads, for example, or steam buns. But it pretty much does affect the whole process between milling and baking and overall production.
Okay.
One last question, unless any of the participants have any to jump in. Juliet, what research, if any, is being done to address high alpha amylase?
So a lot of the alpha amylase funding associated with our big request about 5 to 10 years ago, the WSU and USDA ARS up at Pullman have been researching a couple of different things. One of the things that they're doing is researching the actual genetics associated with late maturity alpha amylase and trying to find ways to get markers to target those varieties that have the susceptibility to low falling numbers. So it's a genetic factor associated with late maturity alpha amylase. So we are looking at ways to actually remove those, as the Australians have done, from their varieties, those that are susceptible. That's one thing. The other thing that I know Camille Stieber and her group are working on, a test, a faster, more reliable test that would replace our numbers associated with the viscosity test. And I am not sure what the latest results are for their falling numbers testing, but they're trying to find a better way to actually measure that so that the variability of the testing is significantly reduced. So variety development is being implemented to reduce the number of varieties that are released with those low falling number problems associated with late maturity alpha amylase. The other thing to think about is, again, the hard reds are less susceptible to, or the soft reds are going to be less susceptible to sprout damage. And then the only other thing that I can think of that is being researched is looking at the environmental factors separate from the late sprout or the late rains affecting sprout. They're looking at varieties that are less likely to sprout, but they're also looking at the environmental factors associated with the induction of late maturity alpha amylase. And I've done quite a bit of work on that, and most of it comes down to, in my opinion, rain events close to harvest, or the late maturity alpha amylase associated with a lot of varieties like Express, Espresso, or some of the hard whites that have that susceptibility. So it's a complex issue.
Yeah. All right, well, we are just about to come up on our 30-minute mark. Juliet, I want to thank you for taking time out of your day to join us for today's podcast. We will take this and we will post it to our social media platforms, our YouTube channel, and also our podcast channel. And then stay tuned. We have a couple more from the fields in the works coming up next week that we will publicize and get that out for everybody. Just want to thank everybody for participating today. We appreciate your time, and have a great rest of your day and week.
Thanks, Ryan. Thanks, Brittany and Jill. Appreciate the invitation to be here.
Thank you, Juliet.